everyone. In this two-part video series, I want to talk about testing in data engineering. Now, testing is a broad topic, and a lot of time people in data engineering do not talk about the nuances for testing in data engineering. The content of this video series rely on my experience in data and software engineering and some of the trainings I have taken in the past. I shall highlight them to begin with. So, unit testing with Python 3 by Emily Page. This was a good course. The second one, which I recommend if you want to go deeper into unit testing concepts, but this one is in C sharp. If you're comfortable with C sharp, maybe that's the right course to take. There are other free materials on the internet as well, such as mine, but testing and more specifically unit testing is a broader concept which cannot be covered in just 1 hour video. The focus of this video is going to be primarily around data engineering. Uh, Before I begin, the code I will be sharing in the demo is hosted on GitHub as well, and that's the link to the repository. And if you want to connect with me on LinkedIn, feel free to do so. All right. There are some prerequisites. My plan for this series is there are going to be two tutorials. Tutorial one, which is this one, I would be covering unit testing, and in the next tutorial, my plan is to cover data quality test. Um, there is some expectations from you while you're taking this series. For unit testing, you should be comfortable with Python and basic object oriented. You should know PyTest. I won't be covering PyTest, so if you're not comfortable with PyTest, take a pause. There are plenty of videos on the YouTube, uh, or happy for you to take the course I recommended um, uh, on plural site. And then you should know basic PySpark. So that's the requirement or prereqs for taking this tutorial. The next one, which would be coming after this, if you know basics of PySpark and SQL, you should be good to go. All right. What is testing and why it's important? So, testing means basically checking, validating, and verifying the actual outcome against the expected outcome. And then, if the actual outcome is the same as expected outcome, we say the test has passed. Otherwise, it's considered failed. And why is it important though? So, the idea is we want to make sure whatever we are shipping to production does not have any errors. Now, there could be two types of error. Some errors we can control, fortunately, but unfortunately, there are some bugs we cannot control. The kind of test or the kind of bugs we can control with some tests, we can call them unit tests, but there are some bugs which unfortunately we cannot control. We can classify those sort of tests, data quality tests. Those arise because of the data quality issues. I should have written data quality tests, but anyways. So, data quality tests, that's what I'm covering in the next video. I should have put a 2 here, but anyways. Okay, let's first talk about data quality tests. What are those? So the idea is validate the quality and integrity of the data itself. There are some examples I've given. Uh, Think of them as maybe a null check on a column, like for example, customer ID int not null, or maybe some checking the uniqueness of a column, right? Or maybe some business logic, such as a constraint on a price, like price should be higher or greater than zero, or maybe a primary and foreign key constraint. All of them somehow relates to data quality. Now, if you notice in all of these cases, developer has little control over them. He can he or she can define this constraint, but he does not own the production data. And any you could have a data that could violate those cases, and how you deal with them would obviously depend upon the constraint. You can flag that data, store it in a different table, or maybe if it's a very business complex business rule, you can store it and then maybe discuss it later on um, with the business analyst and maybe come up with the solution. So this part is what we're going to cover in the next video. But the focus of this video is around unit testing. So what is unit testing? So it's the process of testing small unit of code. That could be a function, a method, maybe a class, and things of that sort. You can think of it as testing maybe an if statement, which is a logic, some sort of algorithm, or maybe a complicated math equation like this. Some trans in if specifically in terms of data engineering, maybe think about some transformation going on, or maybe something like table A join table B, maybe a where clause, maybe a filter, maybe a group by, things of that sort. Now, again, if you notice here, there is very unique sort of theme that's going on here. All of them, like whether that's an if statement, whether some developer has written the mathematically complex mathematical equation, or whether that's table A left join table B, the developer has control over it because it's just the code, right? So if anything goes wrong here, that's kind of a problem on the developer's end. Now, for example, the right way of, let's say, writing the code was table A left join table B, and developer mistakenly wrote table A inner join table B. So we want to test against those cases. Now, the difference between this case and the case I mentioned earlier, the difference is in data quality tests, developer has no control on what data comes into the system. But here, developer, if the right code was to write a left join and he mistakenly wrote inner join, then that's the mistake developer did, and unit test should detect such change automatically or such defect automatically, or he may forget to put up where clause. Okay, some of these things I have mentioned already, but let's just go through them. So there are two most important reasons why you would want to write automated unit test. First, you want to ensure that the code does what you think it does. So you would have some expectation of what your code does. So that's your expectation. But you then also want to test whether your expectation meets, whether the code meets your expectation or not. And then the second important reason why you want to do unit test is to protect it against future regression. Now, regression is because a lot of times your code go through changes, and you would have noticed at one point in time it was running fine, but then after 2 months it stopped working. So we maybe along those 2 months another developer changed some of the code and now something got broken. So we want to be able to test it against these two cases. So we want to be able to detect any bug in a code. Now, when I say unit test, think of it as a code that tests your code. So in short, code that tests your code, right? And there would be a sort of a small piece of code you want to test. Anything that touches a file system, a database, a network, or we strictly do not consider it to be a unit test. And there is a reason for that. Now, the reasoning behind that is the reasoning behind that anything that touches a file system, database, or network, we do not consider it consider it as a unit test is because, let's say, this highlighted part, that's your code. That may be hosted on a Databricks in terms of a data engineering project. It may be a, if that's a web application, it may be hosted on a web server, or it may be an application may be hosted on your Windows. And that's not important. The important part is that's the highlighted part, that's your code which you control. But then it could interact with a lot of external dependencies, like it could interact with database. And in that database, let's say there is a stored procedure which you do not own, which is sort of external code, right? Now that code you do not own, and since if you do not own something, you cannot test it. And so the idea is that any external dependency or any external sort of logic or code, you can sort of only do an integration test with. But since you do not own, the logic or the concept of unit test won't apply there. So again, any code that I have written, I should be able to unit test it. But then any logic that's external to my system, I don't want to unit test it, or it doesn't make sense. Now, now the code we are testing is called unit under test, and that's called like a test case. You could have a test case pointing to specific unit code. Not only that, you could have multiple test cases, maybe all pointing to the same piece of code, maybe testing other things. But the important thing to note that these test cases or these unit tests should be independent of each other, meaning it should it shouldn't be the case that your test case one produce some data and that data is used by test case 2. These tests should always be independent of each other. Now in the demo, which I'll be sharing later, I have used PyTest. But honestly speaking, you do not, like, just to write a basic unit test, you do not even need any framework. Although these frameworks such as like PyTest or unit test, they help you write better unit test because they come up with ton of functionality, like such as test runner and fixtures and so many features. But the idea of a basic unit test is so simple that tools are just tools. I think the main takeaway from this video should be you should be comfortable with writing unit test, what unit test is, and do not go down the rabbit hole of which tool is good. And yeah, so that's the goal. Later you would see I would connect my PyCharm or my IDE with Databricks, and you there are two ways to do it. You can either create a profile and then authenticate via a profile, or you can use Databricks configure, and that's the option I have taken it. uh, you should have Databricks CLI installed though. Now any test has basically three any unit test has basically three steps: arrange, act, assert. And I am pointing this out because once you look at a complex unit test, it's hard to keep track on which step you are. So whenever you're writing a test, it's good idea to comment around which section of the test you are in, and that helps you being on the right track. Let's go them let's go over these steps one by one. Step 1 is arrange. This is where you would arrange your inputs or input data for the unit test. Then step 2 is act. So this is that exact piece of code or exact method which you want to test. So you want to call that method, and that method you generally pass your arrange step into your act step, and then your act step would return something which we would discuss, and then in the final step you compare your returned output, which is your actual output, with the expected outcome or the output. If your expected and actual outcome are same, you pass the test, otherwise it get failed. Now, an important thing to note that is I have highlighted uh, these two things in yellow and then one in orange. So yellow means like input data and expected output. When you start writing a unit test, even before you start writing unit test, you should already have the input data and expected output. These are the things developer provide to the unit test. And once the unit test executes, the actual output, or once act is executed, the actual output is given. So the point is the things that are highlighted in yellow, developer provides them and actual output is given to you by the unit test, specifically the step 2. So in a nutshell, if you do not have input data and expected output, you essentially cannot write a unit test. Let's simply put it this way. Now, there are some challenges, as pretty much in anything in life. Unit test comes with some challenges. The nature of these two challenges are completely different. One is business challenge, the other one is technical challenge. In terms of a business challenge, coming up with the right test data can sometimes be tricky, and therefore sometimes it requires catching up or meeting with a lot of business analysts, because in writing good unit test you need to have a very good understanding of the business problem, right? So what I mean to say, coming particularly in data engineering, coming up with input data might require like a day worth of effort if it's a complex problem. So coming up with the right expectation and right input data might not always be a straightforward problem. You need to make sure you know what you're testing. And the second challenge is more technical. So I don't think we face a lot of that in data engineering. The technical challenge might occur more in traditional software engineering where your code has a lot of external dependencies. But fortunately, in data engineering, generally the code is not very complex. So yeah, if your code has a lot of external dependency, then it can be a technical challenge. Okay, let's look at a basic example I have creating. In fact, let me open my PyCharm and then show you over there. Now I have uploaded all my code onto the repository. You can clone that repository and follow the steps I am showing you. So you can clone the repository, create a virtual environment, activate the virtual environment, and then install the requirements file. Now I have cloned the repository. Sometimes creating a virtual environment and then installing the requirements might take time. So I have done all the steps. I've done step two, from step one to three. I think that's a typo, but anyways, I'll fix it later. Let me show the very basic unit test. So this first basic unit test doesn't cover any concept of data engineering. That's coming afterwards. So I have a function greet, which I want to test. So if I first is I arrange, second step I act, and then I assert. So if I run this, my test pass. But let's just say instead of my expectation being hello but with a capital H, the test the test would fail because these two strings are not equal, right? Now you would say that's a very trivial unit test, and I agree. So in later part of the video, I'll show like a kind of a very realistic example which we can compare with the production scenario. Now, the reason I showed you this very basic unit test is so that you note this pattern of arrange, act, and assert, because even when the test becomes harder in the second part, this would be easier to sort of follow. Okay, that was very easy, right? But the real world is sort of messy. We do not always get such a trivial code to test. Real code, particularly in software engineering, can have weird dependencies in form of classes, object, or functions, and unit test could become a bit difficult in those instances. Now, the question is, you could have a dependency in your code and you want to avoid it. But then the question is, why would you want to isolate? And I think if I go back to what we discussed, if I have a dependency on an external object, I want to isolate because I'm only testing my logic. So that's the main reason. But there are other reasons as well, because let's say you're testing an API, right? And that depends, let's say, on some weather. You want your test to be deterministic, and then that API in itself is not deterministic. So you want your test to to be predictable. If your code is not predictable, then the unit test would fail. And you want to create some isolation, meaning that if there is an external dependency, I think we have talked about this when I mentioned that in a stored procedure, you don't want to test stored procedure, you want to test your code. So anyways, when you have a dependency, you want to replace it, but replace it with what we call in software engineering, we call that term test doubles. Now, what is that? So that's the unit you want to test, but it has some dependency. You want to replace it with testable. What is it? Now think of it as some sort of, you have a real actor, and then whenever the stunt comes, that real actor sort of replaced by a stunt actor, right? So that's the idea. In a real scenarios, we would use the real actor, but whenever a complex scenario or a stunt comes, we just want to replace it with a. Similarly, we would be using real object in the production scenarios, but if we want to test things, we want to replace that object with a testable. Now there are couple of types in testables: dummy object, test stubs, test by, mock object, and fake object. Fake object is the one I'll be using in the coming demo. The ones highlighted in green are very similar. I haven't gone any further with the the ones I have described on yellow, so we can just ignore it for pretty much. I don't think there's a very good use case for them in data engineering. Right. Testable dummy, that's a null object, and it's pretty much not used by unit test at all. Stub, that's very similar to the real object, but it has some hard-coded implementation. Like for example, in terms of an API, think of it as, if it's a weather API, that's always returning like 20 degrees, right? Because you want that to be deterministic. So that's a hard-coded return value. Fake, again, I'm just highlighting them. If you want to go deeper in those concepts, maybe go and take a course. I am just picking up the points very lightly. And then, okay, fake, that's what we have used in this demo. So it's very similar to stub. However, they do have sort of a real implementation. So this time you're not returning a hard-coded value, but you have some real implementation, right? But that implementation is maybe not suitable for production scenario. So for example, If your code has a dependency on some high specs database, you could replace it with maybe an in-memory database because that's cheaper, right? But obviously you won't want to use an in-memory database for production scenario. And then that in-memory database should have obviously same interface methods and stuff, right? Interface is a very common term, which means a contract, and I'm not going into that. But if you want to look into it, yeah, feel free to do so. So as you can see, from dummy to stub to fake, we are slowly moving towards sort of the real implementation. Like fake is more closer to a real object than stub and then dummy. And then mock or spy, let's not go that route to be honest. Okay, there are some techniques how to test the whenever your code has dependencies, and a lot of times, trust me, your code will have dependencies, right? So there are like lots of techniques. Peel, slice. I will only talk about peel because that's what I have used in the demo. But be aware there are like multiple techniques like slice. Monkey patching, I think, is very specific to dynamic languages such as Python or JavaScript. All right. So there's one thing to keep in mind. Your if you find your code is difficult to test, there's a good chance that your code wasn't written correctly in the first place. If it was written correctly, you won't need a lot of refactoring, right? The code that's easy to test, or let's see what hard code or the code that's hard to test looks like. It would have poor separation of concern. The a good sign for that is to look out for a code with very large functions. All of logic is done in one function. That's a very straightaway sign that that code is generally going to be hard, and it would need a lot of refactoring. Like it would have lack of encapsulation. You would have a code that's very easy to test, such as pure function. Pure functions are always easy to test. It's very easy. All right. The strategies I was mentioning, peel because as you peel the banana, slice as you slice an apple. I will only talk about peel, right? And then if you want to go further, the other strategies, because peel is what I have used, then you can also look into other strategies, but I'll only highlight peel. So let's say that's the function you want to test. You have some def in Python, and then that's your code. And then there's some hard code to test, like some external dependencies, the one that's highlighted in yellow. But the one that's highlighted in blue, that's your easy testable code, right? And because of this yellow part, we cannot test it. So what we could do is we could refactor it, right? And what we can do is we have taken the blue part out. So we have kind of peeled the main ingredient of the main banana out of that process and encapsulate it somewhere else. And then from the pink line, we just call it. So now we have isolated the easy part and just from the difficult part. The other strategy slice, not going into that if that's what you want to cover. Now let's come to the main part of the this video. That's the demo part, and that's the part I'm most interested in. Now I have a business use case. There is an ETL pipeline that's ingesting data from silver layer from customer silver table to gold table, right? And the business logic is we need to ingest data from silver layer to gold layer, but if the city is Sydney and the customer code is 5, that data should not be loaded onto the gold table. So that's the business logic, right? Now that's the business logic against I want to write my unit test. So you already need to have a clear business context of against which you're writing the unit test. So that's important. Now, once you have a proper business context, you need to create your own test data for that. And I will talk about that now. Like, why do you need your test data to test your code? Now, I will go back and forth between the demo, like my code, and this slide. So please stick with me. That's the sort of confusing part I want you to sort of analyze. Okay, this part, think of it as your actual code, and then that could have a dependency on maybe a silver layer. So data is going from silver layer to gold layer. Think of it as a silver, as your silver customer table, and then the data would be going to the gold layer, right? Now, on the previous slide, I mentioned you should come up with test data. Now, I get a lot of times this question like, why should I come up with my test data? Why can I not test my code based on the actual data or like let's say production data? Now, the answer to that is because your actual data is not deterministic, like it's not suitable for data for testing. What do I mean by non-deterministic? Let's look at this test data. Now, remember that business use case is anything where city is Sydney and customer code is code 5. That's invalid records, and I do not want to process or ingest that data into the gold layer, right? So how many rows we have got? 6. Out of these 6 rows, these 2 are invalid, right? Now I can do this with my test data because that's the data I created. So I know the distribution of the data, but because that's deterministic, whereas the actual data is non-deterministic, as in I don't know whether today maybe there are 3 customers with Sydney and code 5. Tomorrow maybe there are 5. So my data distribution on actual data always changing. So I cannot come up with the expectation. So if my data is always changing, then I need to come up with some static data. And not just static data, but also I should know the data well, meaning it should be deterministic. So then based on the business logic we discussed, then I can make this claim that given this test data set, my expected output should be 4, like as in 4 rows should go to the output table, which is gold layer, right? So the business criteria all customer except Sydney with the customer code 5. So based on the test data, how many rows fulfill this criteria? The answer is 4, right? And so I store it somewhere on the variable, which I'll just show you in a minute. And then I pass the same data set through my actual code and see what output I get. And if the answer to the question is the actual output also has 4 rows, so then I compare my actual output and expected output. If the answer is the same, then I assume that yes, my actual code is correct. Otherwise, if they are not equal, then I can conclude that there is something wrong with my actual code. So while I am writing my unit test, I have complete trust over my test data because that's the data I come up with. So I know the test data well, right? But I'm not sure about the actual code. So if these two things do not equate, then I can conclude that there's some problem with the actual code. Let's have a look at a demo so I can explain. Now you should authenticate your IDE with Databricks, and I'll quickly show you how you do that. That's also on the README file. So you would write Databricks configure with the condition you should already have a Databricks CLI, of course. And once I have already configured, so I'm not gonna do that. But so once you type Databricks config, it will ask for a host, so you can provide the host, which is this, and then you can create a token. I'll just create a token, and then you can copy that and use that token, and then your Databricks should be or your IDE would be sort of connected, authenticated with the Databricks environment, right? Now also keep in mind that I have already executed these steps. I've created my virtual environment, and then I've installed the packages. If I go to the requirement.txt, I have done, I've installed these packages, right? Now on the Databricks cluster side, I'm using serverless, right? And then I just maintain a global session here, and then wherever that session is needed, I'm just sort of passing it. So that was the basic unit testing, but that's where we are. Okay. Now let me come and run the pre-deployment script. It's nothing. I'm just, so I have two tables in my model, silver table and gold table. I'm doing nothing. I'm just sort of dropping them if they exist. So if I run them, and you can see like I am importing that Spark session from this manage Spark session, right? I've just created one. So because I do not want to run this on each file. Okay, if that file is executed now, if I go to my Databricks environment, and if I go to my Databricks environment, and if I execute this, I have dropped the table. That table should not exist anymore, right? Let me go back. So I've run the pre-deployment script. Let me go and run DDL script. So this time I am doing nothing except that I make sure that the schema exists, and then I'm also creating these two tables, the silver table and gold table. This code is available on my GitHub, so that's why I'm not going into too detail. So just give it a couple of seconds and the table should be. So now the table wasn't there, it's created, but it's empty. Now I've created a dummy script to load or simulate the process of loading silver table. I'm sort of just doing a bulk load, right? As I would run this, this would bulk load my with this would bulk load the silver table with only 100 rows. That should be, yeah, so 100 rows loaded into silver dot customer. So if I now query this again, so yeah, we have got 100 rows. Okay, out of those 100 rows, I want to see how many of those fulfill the criteria of silver equal to Sydney and customer code equal to 5. So two of there are two rows, right? Now obviously I haven't ran the anything on the gold, so gold should be empty, right? That's just a comment. Now I haven't done any unit tests so far, right? That's going to come. But I want to make something which is sort of realistic. Now that's my pipeline that runs and load the data into the gold layer. In this method I'm doing nothing. I just read from the silver layer, right? I haven't done any business transformation, which is what I'm showing you. And then I just write the same data onto the gold layer. And obviously gold layer has surrogate key, but again, not going into that. That's just an auto incremented key on the gold layer. But anyways, I just run this, and obviously I haven't filtered out the cases where the city is. But if I run this, um, if I run this, so I ran this code, and now my gold table has these records which should not have appeared. So there is some issue in my code, right? Now, how do I fix it? And then how do I unit test it as well? Now, I have created a separate file in which I have done refactoring, and I will share you. But if you start looking at it, there is an issue with this code because on line number 9, I have a dependency on the silver.customer. Now remember my PowerPoint slides where I was, you can think of it that exact same scenario. I have a dependency on my actual data, and when I want to run test, I want to swap it. And this is that fake object. The test data is a fake object. I want to swap it, but only during my unit testing. But when my code is running on production, I still want to use the actual data, right? That's the intent actually. So now if I go back, see, I have applied that peeling technique. I have taken the method out, which is easy with the, and then you can see I have made customer equal to none. So by default, I make it none. And then, so from my unit test, I would pass the customer, but in normal circumstance or in the production, this is the code that would run because from my normal method or from my normal function, I'm just calling this without any customer. So if it customer is none, if customer is none, then silver customer is assigned this value, right? What I'm saying is if, for example, A is equal to 1 or none, sorry, none or 1, then the value of A is going to be 1, right? So I'm just using that principle basically. And then afterwards, uh, I have applied that logic here, and that's the thing I want to test. Now, if I go to my unit test, now that's the unit test, right? I have taken that same data set which I was showing on the PowerPoint slides, right? That's the same data set. I have written that as a test data. So remember those three steps: arrange, act, and assert. So in the arrange, I read the data from the existing silver customer, but then I do not read the data. I only sort of read the schema because that's the schema I want to conform to. I call it a customer, silver customer, right? And then because I do not take any data from it, I then append this test data. I then union by name and then sort of I append this data. So that's, I sort of insert this test data into this silver customer. So now I have this test data frame, right? Which I want to pass. So then I pass this test data frame onto the customer. So that's the code then I am testing, right? But there is a difference. You see, the same method is used in two ways. From my unit test, I pass the test data frame, but from my actual, when it runs on production or on this line, then we are not passing any we are not passing any test data. So it picks the default, which is this one, right? Because by default, the customer is none. So it picks the data that's coming from production or the actual data. But under my unit test scenario, I pass the test data and then I count the number of rows. And then obviously my expectation is 4 because 4 of these rows meet the expectation. and then the customer where the city is Sydney and code is 5, we do not want those customers. Now, let me run this test. I can run this test, and then the test has succeeded, right? Because I am testing the refactored code. Now, let's just say I change mistakenly, the developer made a mistake, and instead of code 5, it's code 1. Now, if I come and again run my unit test, my test should be able to detect that change, right? And my test should fail now because, see, my test has failed because the expectation and the actual output doesn't uh, match. Now, and that's the whole idea of unit test. We are testing not the data, we are testing the code. So the right code to write was to check whether we are rejecting these rows, and if that logic isn't implemented correctly, my unit test was able to spot that, right? Now if I have fixed it again, if I come and back come back and run my unit test back again, it should pass. Now think about this. You can write or integrate this unit test into your CI pipeline, and whenever you write new piece of code, if there's any issue, your pipeline would fail and there won't be any deployment on the production. So that's the whole intent. Haven't done I haven't shown the deploying part as in CI/CD, but if you guys are interested, I can show you that maybe in another tutorial. But think about this, that the scenario I have mentioned, it's purely testing the logic. It's purely testing this line sort of 51, right? And in this scenario, we haven't tested the, like, as in the data quality, which is what's the focus on the next video. So if I revise, we have some code. That code might have an actual dependency, which during normal processes we want to use that. But once we are writing a unit test, we want to swap it. And how we swap it, there are multiple techniques. The technique I showed you was, if I come to unit test, you see in the unit test, I'm passing the customer from here. And if I press F12, that takes me to the definition. By default, it's none. So during the normal circumstance or from the production, then I'm just using that hard coded. But during the test, yeah, that's pretty much the main logic. And you would always pretty much have some dependency, and it's how do you isolate it? That can be sort of tricky in a lot of instances. In languages like C Sharp and Java, you have a leverage of using interfaces. I'm sure Python has interfaces as well. So yeah, interfaces can be very handy as well. But yeah, that's the very basic technique I've shown. Now, so I've just taken some screenshot of the case that I've gone through. Um, it, that was sort of the part that I've highlighted was sort of the main logic that we have gone through. Is how do you sort of be able to run the same code differently from your unit test and from your actual code. And that's sort of a very neat trick, I think, can be very useful. Now, that's pretty much it, except that there is a lot of things that we could cover in a unit test. Of course, this wasn't a course on a unit test itself. It was pretty much, I wanted to sort of compile my learnings, what I've taken or I've acquired over the years, and then taking on some courses. But if you're interested in going deeper into unit testing, there are like lot of things that you can go in, like code coverage, branch coverage, approval testing, and all sorts of things you can. And I think you should look into. There's one thing which I've used in the test, which is conf test, and then the idea of fixtures, auto fixtures. and then like because I have yield spark, and then because I have used the built-ins module, because if you come to my test, I do not want to use, or I don't want to pass the spark, and for that I have run something like this. Again, I couldn't cover all what I've done in very detail in only this 1 hour, because there's a lot of so there was expectation that you already know basic Python, PyTest, fixtures, and some PyCharm, some PySpark. That's pretty much it. In the next video, I'll go through how do you automatically write tests to check the quality of your data. Thank you. Sorry, I ran the unit test, but I didn't run the refactoring code. So I haven't yet shown, like, once I run the correct code, we don't get these rows. So let me go and show you that. So I'll just drop the table once again, just quickly go through these steps. That's done. I will run my DDL scripts. That's done. Now I will again load my silver table. That's done. So gold shouldn't have any data now because I have dropped all the tables. Then I recreated the tables, loaded the silver table. Now gold doesn't have any data. Let me run the refactored code, which has the correct business logic. So let me run the gold layer, and it should have all the data except that two rows which we shouldn't be ingesting. So let's do that. If I go to gold, it should have the data now. But if I just search around this where clause, it shouldn't have any data. So yeah, I just forgot to show this. Thank you.
Don't forget to like and subscribe.